Our solar system is a collection of planets, moons, asteroids, dust, and frozen objects that all orbit around one star, the Sun. It formed about 4.6 billion years ago from a giant cloud of gas and dust. As this cloud collapsed under its own gravity, it created a spinning disk. Most of the material moved toward the center and became the Sun, while the rest slowly gathered into the planets we see today. The closer planets became hot, rocky worlds. The farther planets formed into massive giants made of gas and ice. Each planet has its own chemistry, temperature, weather, and history. And together, they tell the story of how solar systems are born. Let's begin our journey from the planet nearest to the Sun. First solar system planet, Mercury. Mercury is the smallest of the 8 planets and the closest to the Sun. Because it is so close, sunlight on Mercury is incredibly intense. Yet the planet has almost no atmosphere to trap heat or block radiation. This causes extreme temperature swings. During the day, the surface can reach over 400 degrees Celsius, while at night it can drop below -170 degrees. Mercury's thin, fragile exosphere is made of atoms knocked off its surface by solar wind and micrometeorites. Its surface is covered in craters, cliffs, and smooth plains, showing that Mercury has been bombarded by space debris for billions of years. Scientists believe the entire planet has slowly shrunk by several kilometers as its large iron core cooled over time. A single year on Mercury lasts 88 Earth days, but one full day-night cycle takes twice as long. This means Mercury rotates very slowly, and the Sun rises and sets in strange patterns across its sky. Second planet is Venus. Venus is often called Earth's twin because it is similar in size and structure. However, Venus is wrapped in a dense atmosphere of carbon dioxide, with clouds of sulfuric acid that completely hide its surface. This thick atmosphere traps heat so efficiently that Venus is the hottest planet in the solar system, reaching around 470 degrees Celsius, hotter than Mercury, even though Mercury is closer to the Sun. The pressure on the surface is about 90 times stronger than on Earth, equal to standing nearly a kilometer underwater. The entire planet rotates incredibly slowly and in the opposite direction compared to most planets. That means on Venus, the Sun rises in the west and sets in the east. Volcanoes, mountains, and vast plains cover its landscape. Some research suggests Venus may still have active volcanism, releasing gases into the atmosphere. Millions or billions of years ago, Venus may have had oceans, but a runaway greenhouse effect transformed it into the extreme world we see today. Third planet, our home. Earth is the only known planet with life, liquid water on its surface, and an atmosphere rich in oxygen. It orbits at just the right distance from the Sun, within what scientists call the habitable zone. This allows water to exist as liquid, solid, and gas, helping regulate temperature and support complex ecosystems. Earth's magnetic field, generated by its rotating iron core, shields the planet from harmful solar and cosmic radiation. Our atmosphere, a mixture of nitrogen, oxygen, and trace gases, protects us from meteors, moderates climate, and helps maintain a stable environment. Earth is geologically active, with plate tectonics that shape continents, create mountains, and recycle materials over millions of years. Its single moon, unusually large compared to the planet itself, helps stabilize Earth's tilt, keeping seasons relatively steady. Fourth is the red planet, Mars. Mars is a cold, dusty desert world with a thin atmosphere made mostly of carbon dioxide. Its reddish color comes from iron oxide, rust, in the soil. Although smaller than Earth, Mars has some of the largest landforms in the solar system. The massive canyon system, Valles Marineris, stretches over 4,000 kilometers, and Olympus Mons rises nearly 22 kilometers high, making it the tallest volcano known. The atmosphere on Mars is too thin to hold much heat, causing temperatures to swing from chilly during the day to extremely cold at night. Dust storms can grow so large that they cover the entire planet, sometimes lasting for months. Evidence of dried-up riverbeds, minerals formed in water, and signs of ancient lakes suggest that Mars once had a warmer and wetter climate. This raises the possibility that simple life could have existed there in the distant past. Today, researchers are especially interested in areas where frozen water might remain below the surface. Fifth planet. Jupiter is the giant of the solar system, so massive that all the other planets combined still wouldn't equal it. It is a gas giant made mostly of hydrogen and helium, with no solid surface beneath its thick, swirling clouds. Powerful storms race across its atmosphere, the most famous being the Great Red Spot, a storm larger than Earth that has been active for centuries. Jupiter's gravity plays a major role in shaping the solar system. It helps deflect comets and asteroids, and it may even have influenced the early formation of Earth and other planets. Surrounding Jupiter are dozens of moons, including Ganymede, the largest moon in the solar system. Europa, one of its icy moons, may contain a vast ocean beneath its frozen shell, making it one of the most promising places to search for life beyond Earth. Deep inside Jupiter, pressures become so extreme that hydrogen turns into a metallic fluid, which may help generate its powerful magnetic field, the strongest of all planets. Sixth planet from the Sun, Saturn. It is famous for its magnificent rings, which are made of countless pieces of ice and rock. These particles range from the size of sand grains to mountains, and they stretch thousands of kilometers across, forming bright, thin bands that circle the planet. Saturn itself is a gas giant, composed mostly of hydrogen and helium. Despite its enormous size, it has an extremely low density, lower than water, which means it would float if there were an ocean large enough to hold it. Saturn has more than 100 moons, each with its own unique features. Titan, the largest, has thick clouds, lakes of liquid methane, and a dense atmosphere rich in nitrogen. Another moon, Enceladus, shoots plumes of icy water into space from its south pole, hinting at a possible ocean beneath its surface. Saturn's winds can reach hundreds of kilometers per hour, and storms can last for years, creating bright bands and unusual cloud patterns across the planet. Seventh planet, Uranus. It is known for its unusual tilt. It rotates on its side, likely due to a massive collision early in its history. Because of this, Uranus experiences extremely long seasons. One pole can face the sun for decades, while the other remains in darkness. It is an ice giant, made mostly of water, methane, and ammonia ices deep beneath its atmosphere. The methane gives Uranus its soft blue color. Temperatures here are among the coldest in the solar system, dropping below -220 degrees Celsius. Uranus has faint rings and more than 24 moons, many of which are oddly shaped and covered in ice. Its winds can reach nearly 900 kilometers per hour, shaping patterns in the atmosphere. Eighth planet, Neptune. It is the farthest planet from the Sun and is similar in makeup to Uranus, but with a deeper, more vivid blue color. It is an ice giant with strong atmospheric activity. Neptune is known for having the fastest winds in the entire solar system, reaching up to 2,000 kilometers per hour. Because it is so distant, Neptune receives very little sunlight, and a single orbit takes 165 Earth years. Its atmosphere contains hydrogen, helium, and methane, with swirling clouds and large storms that appear and disappear over time. Neptune's moon Triton orbits in the opposite direction of Neptune's rotation, suggesting it was captured from elsewhere in space. Triton is geologically active, with icy geysers that spray nitrogen gas into space, making it one of the coldest yet most fascinating moons known. Our journey through the solar system reveals worlds shaped by extreme heat, freezing cold, crushing pressures, and winds beyond anything imaginable. Each planet has its own story, from Mercury's shrinking core to Neptune's raging storms, and together they help us understand how planets form and evolve. Even though we've learned a great deal, the solar system is still full of mysteries. Every mission and every discovery brings us one step closer to understanding our cosmic neighborhood, and perhaps even our place in the universe. Thank you for exploring with me. I'll see you in the next video.